Welcome to an in-depth look at one of the most common chronic bacterial infections globally.
This is the stomach, an acidic environment designed to break down food. But within this harsh setting, a resilient invader thrives. Helicobacter pylori.
Often simply called character in Image 1, H. pylori, this bacterium is responsible for major health issues.
How does it survive the stomach's powerful hydrochloric acid?
The secret lies in its clever defense mechanism.
H. pylori produces the enzyme urease.
Ammonia is a powerful base that neutralizes the surrounding stomach acid.
This creates a safe, pH-neutral zone, allowing it to burrow into the protective mucus layer. The bacteria.
Now, the colonization begins. Once settled, H. pylori doesn't just rest. It begins its attack on the stomach lining. The bacterium has several virulence factors, chemical weapons that cause tissue damage. One major player is the vacuolating cytotoxin A, or VACA. VACA disrupts the host cell's structure and function, leading to cell death. Another critical weapon is the CAG pathogenicity island, or CAG-PAI. This is essentially a molecular syringe. The type I4 secretion system extends and docks onto the membrane of a host cell. It injects a protein, CAG-A, directly into the stomach's epithelial cells. Once inside, CAG-A interferes with the cell's communication and growth pathways.
This disruption can lead to inflammation and, over time, abnormal cell proliferation.
The combined effect of urease, VACA, and CAG-A is a relentless assault. As the mucus layer is weakened and the cells are damaged, the underlying tissue is exposed. The potent stomach acid, now unimpeded, begins to burn the exposed submucosa. This is the formation of a peptic ulcer.
Most ulcers not caused by NSAIDs are directly attributable to H. pylori.
The body's immune system does respond, but often it's a double-edged sword. Immune cells arrive, attempting to clear the infection.
However, because character in Image 1, H. pylori, hides effectively under the mucus, the immune response becomes chronic inflammation.
This continuous, long-term inflammation is called gastritis. The stomach lining appears red, swollen. Chronic gastritis is the precursor to more serious conditions.
The damage slowly accumulates over decades.
Long-standing H. pylori infection can lead to a condition known as atrophic gastritis.
The stomach lining thins, and the specialized cells that produce acid and enzymes are lost.
This process can then transition into intestinal metaplasia. The stomach epithelial cells visibly change.
This sequence, from chronic inflammation to atrophic gastritis to metaplasia, is the main pathway to stomach cancer.
Specifically, H. pylori is the primary risk factor for gastric adenocarcinoma, a type of stomach cancer.
The CAG-A protein plays a key role here, promoting uncontrolled cell growth and survival. It's classified as a Group 1 carcinogen by the World Health Organization. Another rare but serious cancer linked to the infection is malt lymphoma.
This is a cancer of the immune cells in the stomach lining, often reversible with successful H. pylori eradication.
Beyond gastric issues, H. pylori has been implicated in certain extragastric conditions. For example, it is linked to iron deficiency anemia.
The persistent inflammation and decreased acid production impair iron absorption.
It's also associated with immune thrombocytopenia, PRAS, a blood disorder.
The infection triggers an autoimmune reaction that targets the body's platelets.
The severity of disease often correlates with the specific H. pylori strain. Strains possessing the CAGA gene are significantly more likely to cause severe illness and cancer.
Transmission typically occurs through the fecal-oral route or oral-oral route.
It is especially common in areas with poor sanitation and crowded living conditions. Children are often infected early in life, leading to long-term chronic infection if left untreated. How do doctors confirm the presence of this hidden bacterial invader? The most common non-invasive test is the urea breath test, UBT.
The patient ingests labeled urea. If H. pylori is present, its urease enzyme breaks down the urea into labeled carbon dioxide.
This produces labeled carbon dioxide, which is exhaled and detected.
Another method is the stool antigen test.
This test detects character in image 1, H. pylori, proteins directly in a stool sample.
Blood tests can check for antibodies, but they can't distinguish between active and past infection.
The invasive method is endoscopy with biopsy.
During endoscopy, small tissue samples are taken.
These samples can be analyzed using a rapid urease test or histopathology.
Successful treatment, or eradication, is crucial for preventing long-term complications.
Standard treatment is typically a triple therapy. This combination involves 2 different antibiotics and a proton pump inhibitor conin. The antibiotics are essential for directly killing the bacterium. The PPI reduces stomach acid, which allows the antibiotics to work more effectively.
Treatment usually lasts 10 to 14 days. Due to rising antibiotic resistance, quadruple therapy is becoming more common.
This therapy often includes bismuth, which helps protect the stomach and enhances the effect of the antibiotics.
Confirming successful eradication is vital. A follow-up test, usually UBT, is performed 4 to 6 weeks after treatment ends.
Successful eradication dramatically reduces the risk of peptic ulcers and gastric cancer recurrence.
H. pylori is a masterful colonizer, utilizing its unique chemical and physical tools to survive. Its long-term presence causes a cascade of damage, from chronic gastritis to potentially fatal cancers.
The link between this tiny bacterium and stomach cancer is one of the clearest in all of microbiology.
Yet, its infection is treatable, offering a clear path to prevention.
Prevention centers on good hygiene practices.
Washing hands thoroughly,
especially before eating and after using the restroom. Ensuring access to clean, safe drinking water and properly prepared food.
Awareness is the first step. If you experience persistent symptoms, consult a doctor for testing.
Understanding character in image 1, H. pylori, helps us protect one of our most vital digestive organs.
Thank you for exploring the microscopic world of the stomach with us.